Series and parallel circuits explained for HVAC technicians. Welcome to Class 11, where we'll dive into one of the most important electrical concepts for HVAC, series and parallel circuits. You'll see these two types of wiring everywhere in thermostats, relays, contactors, blower motors, float switches, and heaters. If you want to troubleshoot with confidence, you need to understand how power flows through these circuits, what happens when something fails, and how to wire each type safely. Let's break them down step by step. What is a series circuit? In a series circuit, electricity flows through one single path. Each device is connected in line, one after another. If any device in that chain opens, the circuit is broken and everything stops working. Series wiring is mostly used for safety devices. 24-volt series example, float switches. Think of a 24-volt red wire, R, leaving the transformer. It doesn't go straight to the thermostat. Instead, it flows through. Float switch in the emergency drain pan, drain line switch, AquaGuard or PVC inline switch, and only then reaches the thermostat R terminal. These are wired in series, using a single wire, usually black, and if any switch opens, the entire system shuts down. Why? Because the 24 volts can't reach the thermostat, no signal goes out, and the condenser and blower stay off. This prevents water damage when there's a clogged drain. 240-volt series example, electric heater safety. Let's now talk high voltage, 240 volts. Electric heaters and air handlers have built-in series protection using high-limit switches, thermal fuses, airflow safety sensors. Here's what happens. Power comes from the panel, black and red wires, and enters the heater kit. Before it gets to the heating elements, it passes through safety switches, wired in series. If the unit overheats or airflow stops, any of those switches will open, cutting off power to the heater. That's a 240-volt series safety circuit. One break shuts it all down. What is a parallel circuit? A parallel circuit gives electricity multiple paths to travel at the same time. Each device is powered individually across the same power source. If one component fails, the others keep working. Most control wiring in HVAC is parallel, especially when sending 24-volt signals to relays and contactors. How parallel circuits work in HVAC, 24-volt control. Let's say you have a 24-volt transformer. It gives you R red, 24 volts hot C, common, return path. Now imagine three components, thermostat, contactor, relay. Each one connects between R and C separately in parallel. They each get full 24 volts because they have two wires, one wire from R, one wire to C. If one device fails, the others are unaffected. This is how we control blower relays, condenser contactors, reversing valves, smart thermostats, all powered by 24 volts parallel connections. Do we use parallel with 240 volts? Yes, especially in equipment with multiple independent loads. Example, inside an air handler, the blower motor, heat strips, and condensate pump may all be powered by 240 volts, but wired in parallel across the same circuit. Each device has its own path from L1 to L2. If the blower fails, the heater still gets power. Why this matters? When troubleshooting, if everything dies at once, think series. If some things still work, think parallel. Use your multimeter to test across points between R and C in low voltage, between L1 and L2 in high voltage,